back to Jackson Squared. Today we're looking at TEK 6.12a and 6.13a, which say interpret numerical data summarized in dot plots, stem and leaf plots, histograms, and box plots. 6.12 says represent numerical data graphically, including dot plots, stem and leaf plots, histograms, and box plots. So far, we've looked at the dot, we looked at the stem and leaf, we've learned about histograms. Now is our time to learn about a box plot. A box plot displays a data distribution using 5 key numbers. Those key numbers are the minimum, that is the smallest piece of data, the maximum, which is the largest piece of data. We have the median, which is the middle of the data set. We have the Q1 or quartile 1, which is the median of the lower half of the data set. And we have Q3, which is the median of the upper half of the data set. The difference between Q3 and Q1 is called the interquartile range. That is a measure of spread. Remember, we talked about range being a measure of spread. Now we're talking about interquartile range, which is the other piece of our measure of spread. It is called a box plot because it includes a box, and then it has 2 lines extended from it. We used to call it a box and whisker plot because it has a box and these little lines look like whiskers or cat whiskers. So I know this is a lot of vocabulary, but let's jump right in and figure out how to create every other set of data. The first thing we want to do is put our numbers in order from least to greatest. So I'm looking at my data and looks like the smallest is going to be 34. Then I have some 40s. I have 45. I have 47, 48, twice, 49. I have 50. So notice how I cross out my numbers to make sure that I've gotten everything that I need. So we're going to start with the easy stuff first. So our minimum is going to be 34. That's our smallest number. And our maximum is going to be 50. That is our largest number. Then the next thing you always want to get is your median. What's in the middle? So I'm just going to lightly cross these out. And so I'm left with something in the middle. So in the middle, I am left with 48. Okay, so I'm left with 48. I have 7 pieces of data. So in the middle, I have one number, and my one number is 48. So 48 will not be included in my upper and lower. So everything to the left of 48 is now my lower quartile side. And we need to find the median on this side. So on this side, I'm going to have just these 3 numbers. I'm going to cross out, and then I'm left with 45. That's going to be Q1, my lower quartile. Then on the right side of 48, I have 3 numbers. I'm going to cross them out, cross, and I'm left with 49. That's my Q3, or my upper quartile. So typically what we do, as you see, we have a number line here. You can start by placing dots and then we'll connect them. So my minimum is 34. I'm just gonna guess and put a dot like there. My max is 50, so I'm gonna put a dot here. My median is 48, so 48, let's say 48 is about here. Then my Q3 is 49, so it would be there. And then my Q1 is 45, so it would be there. So then I'm going to take my Q1 and Q3, and those create my box. So I'm going to box these dots in. My median, that one goes from top to bottom of the dot box. So that's my median. And then I'm going to connect these to my whisker points. And I made this dot way too high. So this is my box plot. This is what my box plot would look like. Here is my minimum of 34, my maximum of 50, my median of 48, my Q1 of 45, and my Q3 of 49. So that's how you make a box and whisker plot. You just need those 5 points. And of course, we're going to do 2 more And I'm going to tell you guys some other things about box and whisker plots as well. Next, we want to go ahead and put these in order from least to greatest as well, like we did on the last problem. We're going to start with 7. Then I see I have an 8. Then I see a 9. And then another 9. And then I see a 10. I see 11, 11. I see a 12. No 13, but I see a 14. I see 2 15s. I see a 16 and a 19. So I just want to verify everything is marked off. Cool. So my smallest number is 7. My minimum, my maximum is 19. Then we want to figure out what is the median, what's in the middle. Here, 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 here. My median is 11. That's what's in the middle. That is what's left in the middle. So then all of these will be my lower quartile. So I'm going to eliminate those to see what's in the middle on that side. Here, 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 here. I'm left with 2 9s in the middle. Okay? So I add and divide by 2. 9 plus 9 is 18, and half of 18 is 9. So Q1 or quartile 1 is 9. So then I'm going to do the same thing on the other side. This is my upper quartile. And I apologize for all the erasing and stuff, but this is the easiest way for me to kind of model it. This one, this one, this one, this one. So this time I'm left with 2 15s in the middle. There's nothing in between 15 and 15. That's 30. Half of that is 15. So that one was pretty nice, right? So we're going to do just like we did last time. We're going to place our dots. So min is 7. 5. Let's see, 6, 7. Put it out about maybe here. Max is 19, so it'll be right here. Median is 11. I'm going to make that here. Q1 is 9. So that's there. Q3 is 15. So remember, Q1 and Q3 make up my box. So I'm going to connect these and make the box. Then my median goes from top to bottom of my box. And then I connect my whiskers. So that's what my box plot will look like for number 2. Let's see if we can get into number 3. Use the given box plot to determine the 5-number summary. So the box plot is already done for us. What can we identify? I believe my minimum is 11. I believe my maximum is, I'm going to say 18. This one is kind of like an approximation. My median is definitely 14, right? Right there. So my Q1 is in between 11 and 14. It could possibly be 12. So I'm going to put an approximate sign that it's approximately 12. I don't know. It looks about 12. Here, this one is probably 16. So I'm going to say that's about approximately 16. So I put those approximate signs because I really don't know. They're like 4 points in between, and I'm kind of guessing. But that was easy. I was able to do my min, my max, my median, my Q1, and my Q2. So things that we want to know about our box plot. First of all, your median represents 50% of your data. That's half of your data. Half of your data going this way, half going that way. So this is like a percent bar, kind of. So minimum, of course, would be 0%. Your max would be 100%. So we're talking about our box plot and the box plot percentages. We know that the median, the number in the middle, is 50% of the data. We know the min is 0%. We know the max is 100%. The lower quartile represents 25% of the data, and the upper quartile represents 75%. The box plots will always look differently based on the data, but the percentages will stay in those same 5 places. So even if I went to example 1, This would be 0% of the data. This would be 25% of the data. This is 50% of the data, 75% of the data, and 100% of the data. The median is always 50%. The quartile 1 is always 25. Quartile 3 is always 75. The maximum is always 100. The min is always 0. Okay? Something else I wanted to think about or talk about since I was doing this is sometimes you may not have whiskers. So don't always think you're going to have a box flat and you're always going to have those whiskers. Sometimes your Q3 is the same as your max. There's sometimes when your Q3 could be the same as your max and you just end with a box and there's no whisker on the other side. Okay? It could be the same for your Q1. You could just have a box plot with no, I want to say strings attached, like no whiskers or no strings attached. So if you ever get one like that and you may see one where there's no tail hanging off it, it's okay. It happens. So definitely that can happen. So I'll go ahead and label this one as well. Like I said, the points are always the same. This is going to be 0 all the time. This is always going to be 25. This is going to be 50. This will always be 75, and your max will always be 100%. So just because they look differently, it's about the data distribution. Some of them are skewed right. Some of them are skewed more left. This one looks more like a perfect distribution, ideal distribution where it looks. So we talked about this Monday, right? So this is clearly in these 3 examples, you see the distribution difference. So I hope this helps. Let's go practice.